All right, moving on to basic probability. We are still in section 1 still here. We have not moved on to section 2 yet. This is a fairly large section, so we moved on to, you know, unit 4, section 1, part B, basic probability. So just some basic probability stuff that we are going to see. So some of the basics here. Like we mentioned earlier, probability is an event that's between the numbers 0 and 1. All the outcomes. So if you take all the probabilities in a sample space and you add them all together, they have to equal 1 or fairly close to 1, rounding issues. But if you take all the probability of rolling a die and you have all the numbers, it's 1 out of 6, 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 1 out of 6. Since you have all of those, if you add all those up, you end up getting 1. And the probability of an event not occurring would be 1 minus the probability of an event occurring, obviously, because if everything is equal to 1, then if we know, oh, it's a 30% chance that I'm going to go to school today, that means that there's a 70% chance that you won't go to school, because both those, either you are or you're not, have to equal 100 or 1. All right, so complements of each other. So this is referring to the not, okay? So when I mentioned, like, this is not occurring, or whatever it is, the notation is a to the power of c, capital A. So the event to the power of c is talking about the complement, so it's going to be the opposite. So if we're talking about rolling a, if my probability of rolling a 3 is 1 out of 6, the complement of that would be 5 out of 6, because it's all the other ones. Okay, so it's the other half. So these are a few different ways that we could set it up. So the probability of A is equal to 1 minus the probability of the complement, which is the probability of the yes is equal to 1 minus the probability of the no. The no is equal to 1 minus the probability of the yes. And then if you take the two probabilities, the yes and the no, they have to equal 1, because that's how it goes. Next up is mutually exclusive. Okay, so when something's mutually exclusive, that means that they are they have no outcomes in common. Okay, so they are completely separate from each other. So there's no overlap. Probability of rolling a 3 or a 4. Okay, on a dice. So what's the probability of rolling a 3 or a 4? That would be your mutually exclusive, because they're separate. So what we would do is we take the bottom equation down here. Okay, you would take, for an or, the probability of rolling a 1 and the probability of rolling a 4, and you would just add them together. Okay, now they're not going to occur at the same time, so I can't say what's the probability of rolling a 1 and a 4 with one die, because you can't. Okay, it's not possible. So that's why our mutually exclusives occur. Okay, so you would be adding them if it's an or. Okay, so if you're rolling two different colored die, what's the probability of rolling the sum of 5 or 2 even numbers? Okay, so 5 or 2 even numbers. You cannot get the number 5 with 2 even numbers. I mean, try to add two even numbers together to get you 5. You can't. Okay, it'd be 1 and 4, or 2 and 3. Okay. Now, if you have 2 dice and you're rolling it, there are 6 by 6 outcomes. So there's 36 total outcomes that are possible. Okay, which if you look at the review sheet or the note sheet, you should see that there's all of them. And when we're talking about this, we usually have 2 different colors, because we want to be able to distinguish between the two. Okay, so since the even and the 5s are mutually exclusive, they are separate, we can just add them together. So it's the sum of 5 or 2 even numbers. So if you look at your chart and you count it all, you'll be able to see that there's 4 sums of 5 on there, and then there's 9 pairs of even numbers that are on there as well. Okay, so we'd go 4 over 36 plus 9 over 36, which gets us 13 over 36, which is the probability of rolling a 5, a sum of 5, or 2 even numbers. Okay, because they are mutually exclusive, they are separate. So we can just add the probabilities together if there are no overlaps. All right, so let's do an example with this. All right, so online courses are growing in popularity, yada, 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 fluff, fluff, fluff. Okay, so the table below shows the probability for given ages. So from 18 to 23, that's the chances of somebody, an undergrad student taking online courses is 0.57, 24 to 29 is 0.17, 0.14, and over 40 is 0.12. Okay, so those are the probabilities for each group. So the first question is show that this is a legit probability model. Okay, now to do that, what is true about all probability models? They have to equal what? When you take the sum, they have to equal 1. So what we'd do is we'd add all those up and we'd see if we get 1. So 5.7 or 0.57, 0.17, 0.14, 0.12. Add all those up and you get 1. So we would say yes, it is a legitimate probability model. Okay, it does work. So now the next question, since it is a legitimate probability model, we're good. We can move on to the next thing. If it wasn't, then we wouldn't be able to answer anything else because we're missing some probability somewhere. So find the probability that the chosen student at random from this group is not in a traditional college age group, 18 to 23. So there's two ways that you can do this. You can either find the probability of all the other ones. So 17 plus 14 plus 12. So you add up all of these and you see what you get. And when you add up all those, you get 43 or 0.43. Okay. So you could add up all the ones that don't follow it, or like this first one down here, the probability of not college age would be 1 minus the probability that they are college age. So it would be the complement of the college age. So since college age is 57, we would go the opposite of it, essentially, which would be 1 minus 0.57, which is 0.43. So both methods will work. So you can either go 1 minus the number or of the probability of yes, or you can add up all the other ones. Sometimes, like in this example, probably adding 0.7, 0.14, 0.12 is most likely what people would do because it's fairly simple. But if we have a lot of other groups, let's say there was about 12 categories, it's going to be easier to just go 1 minus that 0.57. Okay, so last example here. So imagine rolling a 6-sided die, 2 of them, and they're known as fair. And basically what fair means is that they are not rigged in any way. You know, it's not going to show up as a 3 more often than everything else. It's fair. Every side has a 1/6 chance of occurring. So 2 6-sided die, 1 red, 1 white, separate them so we don't have the overlap. What's the probability of rolling a sum of 6 or 2 even numbers? Okay, so a sum of 6 or 2 even numbers. Okay, now with this one, what we have to do is we have to look at, are they completely mutually exclusive? And the answer to this is no, they are not mutually exclusive, because you have an overlap. Okay, you can have 2 even numbers that do add up to 6. Okay, 3 and 2 and 4. 2 and 4 would add up to 6. So what we'd have to do is we'd have to find the probability of both of them occurring and then subtracting out the one that would be the same. Okay, the one that can occur. So the probability of rolling a sum of 6 is 5 out of 36. Okay, the probability of rolling a 9 or 2 evens is 9 over 36. Then how many of those double up? And there's 2 of them, the 2, 4, 2, 4 combination of the red and white. That's the only time you'll have a sum of 6 in which they will both be even. Okay, so what we'd have to do is that we'd have to take the probability of both. So for this or, since they're not mutually exclusive, we have to subtract out the and. Okay. Now, usually we would subtract out the and, but when we were talking about previously with it being mutually exclusive, that and part was 0 because they had no overlap. This is the quote-unquote general addition rule. You take the probability of A plus the probability of B and subtract out the overlaps of them. And that's going to find your probability, which in this case would end up being 1/3. 5 plus 36 minus 2 is equal to 12 over 36. And with this, I would recommend not reducing the fractions until the very end, because then you don't have to, you can just add the tops together and you keep the denominator. Okay. All right. So again, if they were mutually exclusive, the A and B, probability of A and B would be 0. And so that's why when they're mutually exclusive, we don't add, we don't subtract out anything, because that probability is 0. All right, that's the end of section 1. There are more examples that you can work through, which would be beneficial. I highly recommend it. And I will see you guys on to the next section.